Can I go ahead and we wait for others? We have 16 people, 17 people on the call right now.
So I said we can start at 3:05, but in the interim, you can just get to know who is on the call, brief introduction, so on and so forth.
So we have Engineer Mabu. Engineer Mabu, maybe you can introduce yourself.
Okay, thank you, Dr. Amina. Good afternoon, the chapter chair, and good afternoon, our guest speaker, Associate Professor Anas Bisu. Good afternoon, our IES members and volunteers, and also guests on the call. My name is Engineer Peter Chukwunonso Mabu. I'm joining from Lagos, Nigeria, and I am the Publicity Secretary of IEEE IES Nigerian chapter. Thank you.
You're welcome, Engineer Mabu. So, any other ESCO on the call?
Yes, we have Engineer Temitoba Ajayi on the call. Temitoba, you can unmute and speak.
Good afternoon, everyone. My name is Temitoba Ajayi, and I'm joining from Italy. And I'm also the Assistant Secretary for IEEE IES Nigeria. Thank you.
Yeah, you're welcome, Engineer Temitoba. Engineer San, we can see you on the call.
So I think there's no taker. You can go on to another person. Yeah, thank you.
Okay, please. Who is next? The next person can just go ahead and unmute. Honestly, I can't identify everybody just from the name.
Sir, thank you. Okay, let me call on the names so we can be fast. I can see, is it Rabia or Rabiu? Please introduce yourself briefly so we can. Unfortunately, she dropped. Okay, Ademola, briefly introduce yourself. Yeah.
Okay, Ademola Oshodi, member IEEE, and also technical support lead of TabReady. Thank you.
Okay, thank you. So we also have Abdullah. Briefly introduce yourself. Yeah, thank you. Umar Farouk. Brief introduction, sir. Okay. Okay, so Gabriel, briefly introduce yourself. I think we're...
Good day, everyone. My name is Gabriel. I am the Secretary of IES Nigerian Section Chapter. Thank you very much.
Okay, so without wasting much of our time, I'll hand over the mic to Dr. Amina to continue the moderation section. Thank you so much.
Thank you so much, sir. So you are all welcome to today's webinar. The Nigerian Southeast Joint Chapter IES Society. So quarterly webinar topic of today is towards carbon neutral 6G networks, the role of industrial electronics and smart energy systems. So we have on our list the guest speaker who is already here. So next, Mr. General, next. So the agenda for today's session is we have the opening session, and which we have done already with the introduction of the people on the call. Then the next will be the chair's opening remark in the person of Engineer Otto Obong, who will give us the opening remarks for today's session. So, Engineer Otto.
Okay, thank you. Without wasting much of our time, I want to sincerely appreciate everyone for joining this call despite busy schedules and weekends, holidays and relaxation. I want to say a very big thank you for finding time to be part of what we are doing in educating the community. And we're also looking at receiving a good knowledge sharing section from our guest speaker in person of Prof. So I hereby open this webinar for good enlightenment. Thank you so much.
We really appreciate. So our guest speaker for today is Associate Professor Anas A. Bisu. So we are honored to introduce our distinguished guest speaker today, an accomplished Associate Professor of Electronics and Telecommunications at Bayero University, Kano. With over a decade of academic and industrial experience, Dr. Bisu has made significant contributions to research, teaching, and innovation in the field of communication engineering. He holds a PhD in communication engineering from Durham University, along with advanced degrees from the University of Portsmouth and a postgraduate qualification from the University of Oxford. His career spans international collaborations, including his recent role in the Integrated Telecoms Hubs program, as well as contributions to major global research initiatives, such as the EU Horizon 2020 and UK GCRF projects. Beyond academia, Dr. Bisu brings valuable industry expertise, having worked with leading organizations such as Alcatel, Lucent Technologies, and SAWO, and the Hellenic Telecommunications Organization. He is also a leader in cybersecurity and innovation, currently serving as Chief Cyber Risk Advisor and as the founder CEO, Teletronics Engineering Solutions Limited. He is a recognized member of prestigious professional bodies, including IEE, IET, and ACM. Dr. Bisu has received numerous awards for excellence in research and teaching. His dedication to mentorship, innovation, and advancing technications makes him an inspiring voice in the technology landscape. Please join us in welcoming our guest speaker, Prof. Anas A. Bisu. Please, can I see some emojis as we welcome our guest speaker? So, at the end of the session,
thank you.
We have a question for I have a lot of questions ready before before you even start.
Okay. Thank you so much, Dr. Amina. You have been a wonderful person to invite me to this great union or society, IEEE Industrial Electronics Society. So may I share my screen with you so that I can share the slides? Let me try.
Yes, you can go ahead.
Okay. Let's see. I'm looking for the tab.
So while we wait for him to put on the slides,
yes.
So I would like to remind you all that after the session, we have a Q&A. Before the next presentation, we open our cameras to take a photo.
Mm-hmm.
So are you having challenges sharing docs?
Yes, I'm trying to select the. Let me see. I don't want to share the entire screen. I'm trying to select the window, but looks like
no problem.
find the slides. Okay, let me see. Maybe I can. Can you see the slides now? Hello.
No, we can.
Hello?
No, I think we are seeing the desktop. Your not the slide. Maybe have you opened this? No.
Okay. Let me stop sharing. Let me share again. I can't seem to find the. Okay, let me see now. I think I got it. Tell me, what can you see now? Can you see the first slide? The Tamina?
Okay.
Hello.
It's blank from my end. I don't know for other people.
Okay.
So please, can anybody see the slide?
How about now?
No, not at all.
No?
No.
No.
Just taking time to.
So,
No? Should I give it a little bit of time? You can't see still?
We can see the screen.
Yeah,
You
but
can
not the
see your
slide.
system, but not the slide. Okay, I think you've taken off the slide and the screen.
Mm-hmm. All
but
together?
It's blank. Yes, we can't see anything.
Yet.
Or can you send to somebody so that we
Okay, so from your end you can
yes.
share it.
Yes.
All right.
So let's speak to Engineer Peter.
Okay, I can share with me so I can share from my side. I can share it.
All right, okay.
Okay.
Just drop it from the chat. Who should I send to?
I mean, send to me.
Okay. You
can send to me via WhatsApp.
All right, okay. Apologies for this little bit of glitch, so I have to do the. I don't know why, maybe it's
So while we await the slides, can we just give a brief, Engineer? Also, can you give us a brief about the society while we, instead of what's waiting and.
So did you receive it, the Tamina? The Tamina, did you see
yes,
it?
received. Yes,
okay.
Yes, I have received.
So still, I will try to see if I can connect from my system here. I don't know why it's Can you see now? Can you see?
Yes. Yes, we can see now.
Yes, okay. Now we can see it. Yes, it's okay now.
All right, okay, thank you. Sorry for that little bit of glitch. I think I have a lot of windows open on the system, so probably finding it difficult to. So thank you. Without wasting much of the time, thank you for the introduction, Dr. Amina, and thank you the executives of the IES for inviting me. So this is the brief outline of what I'm going to present today. One, starting with the motivation, and then we look at 6G at glance, what 6G is going to come up with, and then look at the energy performance or predicted energy performance of 6G networks. Then we look at also why sustainability matters in 6G, and then carbon neutrality in 6G networks. Also, we look at the potential technologies where we're going to look at the role of industrial electronics and smart energy systems towards carbon neutral 6G. Then we summarize and give some future direction. So looking at the background or motivation behind this presentation is telecom sector really account for about 1% of global energy usage as reported by Bell Labs. And this value could increase up to 3% by 2030. This is when 6G is going to be rolled out commercially. Then we have 6G use cases and performance that demands energy increase or energy usage. And this is due to reliance of 6G high frequencies that we are going to use for 6G, which is going to go up to sub-terahertz frequency. And then the ultra-dense infrastructure that is required to cover a specific area for 6G network or cells. This will increase invariably if you have energy consumption, then there will be increase in carbon emission over a comparable coverage area. The ICT sector in general, that's information and communication technology, accounted for about 1.5 to 4% of global greenhouse gas emission in 2023. So we'll see some of these things and whether they have stopped or they are going to pick up again. So this actually raises a concern and the need to mitigate 6G energy consumption and carbon emission through energy efficient and carbon aware network design. So sustainability is co-design criteria in 6G, not just an add-on. It's going to be a co-design requirement for 6G networks. So sustainability really matters in this regard. So what is 6G? This is what we need to understand so that we know why is it going to consume more energy compared to 5G, and why are we emphasizing on carbon neutrality in 6G? 6G is our next mobile wireless technology for the next decade. As you are aware, or some of you are aware, that after each 10 years, there is new generation of mobile wireless technology. So the next decade, for the next change from 2020 to 2030, we're going to be using the 5G, but from 2030 beyond, we're going to have 6G, which is under development and research. This is designed to create new opportunity, that's the 6G, and meet demands of the decade. So there's going to be a lot of connectivity increase, a lot of user applications demands, and then so we're going to be data driven much more than we are today. So these 6G networks will deliver extraordinary performance, which is 10 to 100 times more than 5G. And this could unleash new possibilities across sectors in both healthcare, agriculture, entertainment, industry, aviation, and other sectors, and also benefit society by creating more and more application and enabling more and more technologies. 6G will provide intelligent fabric for cloud, edge, fog, and AI. So 6G is designed beyond just a mobile connectivity and broadband increase in data or bit rate or increase in latency, but also a new change, which they have called AI and cloud native kind of communication. So it has about, we'll see that in the subsequent slides. This will be an open, secure, interoperable with predictable, verifiable performance. So what are the priorities of 6G? It's about connectivity, yes, just like the 5G, also enhanced performance. And then the difference is increasing programmability, also looking at energy and cost efficiency. So these are the things that 6G is bringing or is prioritizing. Also sustainability, looking at the energy efficiency, then sustainability is part of those priorities. Intelligent Fabric will be platform for innovation across thriving ecosystem. So we'll be having a lot of AI data centers that requires a lot of energy and then a lot of speed and then storage. So these are the key things that actually communication enables: processing, storage, and transfer of information. So IMT 2030, developed by ITU, International Telecommunication Union, in 2023, summarizes the usage scenario and also the design requirement for 6G networks, and try to put it so that we can see the difference between 6G and the 5G. If you look at the triangle, the green triangle in the middle, that's IMT 2020. This is the 5G vision, which is accomplished for now, and maybe 5G advanced increases a few of what this stands for. So EMBB, enhanced mobile broadband, massive machine type communication, ultra reliable, low latency to about 0.1 millisecond. So some applications, and this 5G really enabled the AI that we are seeing today, because without the 5G speed, 5G latency, some of the applications and processing ability, and also the bit rates cannot be, the AI cannot be enabled. So AI, I think, roll out around 2020, almost the same time as the 5G. But today, we are looking for enhancing the EMBB to a massive communication. So 6G is bringing this new enhancement. And also we still have massive connectivity and communication, but 6G is going to bring more of that. So there will be more devices to get connected, but there are completely new capabilities from 6G, which is given in blue: integrated sensing and communication, AI and communication, because there is this debate of AI for telecommunications and telecommunications for AI. So there will be mutual benefits. This is enabling this, and this is helping this. So we are also considering ubiquitous connectivity, which is like digital inclusion, connectivity for everyone, which 5G did not bring. But today, we have seen a lot of work to be able to establish this digital inclusion for everyone to get connected. Then the latency enhancement will be also hyper reliable instead of ultra reliable. So it's going to be reduced by about 1/100. So it's going to be like times 100 less of that of 5G. So this can enable a lot of applications like real-time applications, XR, VR, augmented reality, or metaverse. So the design requirement here, that whenever you're designing these usage scenarios and trying to improve any capabilities, you have to look at sustainability, you have to look at connecting the unconnected, that's inclusion, and you have to also look at connectivity everywhere, which is ubiquitous intelligence or ubiquitous connectivity. Then there is aspect of security. So the more you connect, the more there will be attack. And this is wireless system, remember, so anyone can intercept wireless signal and probably make sense of what is being transferred. So still, before we move to 6G, we have some transitions. Before we have just 5G, and then we move to 5G advanced, where we improve a little bit of latency, improve a little bit of mobile broadband connectivity, data rate. I think the vision usually will give you a range. Let's say we are looking for 10 gigabit per second for EMBB aspects, but probably during 2020, we may not be able to achieve that. So a lot of work on the being done by researchers and industry to be able to reach this advanced level. So moving from 5G advanced, we are moving to 6G, where you have this 3 other new capabilities that I have mentioned: ubiquitous connectivity, integrated sensing and communication, AI and communication. Then there will be new enhancements, new capabilities, new enhancements. So from triangle to hexagonal for 6G. So we are multiplying the capabilities and enhancement of 5G by at least 2 times. These are some of the new capabilities in blue, and in green, these are enhanced capabilities. So the ones in green, they already exist in 5G, but they are going to be multiplied and improved. But these ones, they are completely new capabilities for IMT 2030. So IMT 2030 International Mobile Telecommunication Report is about 6G. That of IMT 2020 is about 5G. So all enhancement and new capabilities for 5G can be found in IMT 2020, and that of IMT 2030 will be 6G completely. So if you look at this, the latency here from 1 millisecond to 0.1 millisecond enhancement, and then up to 0.01 millisecond could be. And then the connectivity, connection density from 10 to the power of 6 to 10 to the power of 8. This is about 100 times more connection density in 6G compared to 5G. Though there is massive connectivity in 5G, but you still have 100 times more connectivity in 6G. And that tells you something, that there is going to be more energy consumption, because the more devices you connect, the more base stations you establish, the more radio equipment you put in place, then it means there's going to be more power consumption or more energy consumption. And that could lead to greenhouse gas emission, carbon emission, that may be due to the fossil fuel that is being used to power these devices. But this coverage, the ubiquitous connectivity, is completely new. Positioning, enhancing the resolution for the positioning up to from 1 to 10 centimeters. Interoperability is new thing. In this regards, there is issue of integrating both terrestrial and non-terrestrial networks, which 5G does not have. So maybe in the future, beyond 2030, we may be able to see a mobile phone connecting to Starlink satellite without buying Starlink equipment. So that interoperability is being worked on. Research is undergoing this. I've done some work on integrating this. And then sustainability. 5G do not look at sustainability of networks, but 6G is looking into that as part of the core design requirement for 6G networks. Then AI. Before 5G rollout, there wasn't anything known as AI in terms of application, but in terms of, say, machines like robots. Before this, what people nowadays know as AI, like ChatGPT, Gemini, people that are in engineering knew what control systems are, robotics and automation. There are also some sort of AI systems, but I think generally today, people refer to AI as mainly the application that you use to maybe get some information. Sensing related as well. So these are the new capabilities and the enhanced capabilities for comparing 5G and 6G. So in terms of spectrum, this is another thing that is going to add energy consumption, because you have more bandwidth, and usually anyone in physics engineering will definitely know the relationship between the energy and the frequency is directly proportional. If you remember, E equals to HF. As you increase the frequency, you increase the energy consumption or energy production. So 6G is going to use, I think, about 3 to 4 bands, which are more than that of 5G. 5G is still using, I think, millimeter waves, 6G and below, and maybe some applications or some systems may be using up to above 6 gigahertz. But for 6G, you can see it in green. What is being proposed for 6G usage from 6 gigahertz up to about 300 gigahertz, or some say up to 0.3 terahertz. That's about sub-terahertz frequency, and moving maybe 6G advanced could explore more terahertz frequencies. So that signifies another point that energy consumption is going to be increased. So you have sub 6 gigahertz currently used by 5G networks. You have upper mid band centimetric wave, 7 to 30 gigahertz. And then you have the millimeter wave band, 30 to 90 gigahertz. This is for data intensive applications like VR, AR, XR. And then sub-terahertz, 90 to 300 gigahertz. So these are bigger frequencies. So usually when you increase the frequency, the system that are going to be designed for that frequency, they will consume more energy compared to the ones that do not. We have increase in bandwidth, but also there is a decrease in coverage. This is another point that you need to look at to see where energy is going. You have more bitrate, more bandwidth, but at the same time, you're reducing the coverage area. This is what this graph is saying. It is telling you that when you move to sub-terahertz frequencies here, you have more bandwidth, but you have less coverage on the x-axis. Also, look at this low band, less than 2.6 gigahertz, the ones that are used for Wi-Fi now, and then the other systems like 4G and 3G. They cover huge area, but they have low bit rate. But as you move up, you have bigger bandwidth, but the coverage is being reduced. What this means, you need more cells to cover a specific area as you move up, but you compensate with the high bit rate. So in a nutshell, key performance of 6G can be considered, just comparing it with 5G. You can see the peak data rate for 5G is 10 to 20 gigahertz. I don't think we still achieve up to 10 gigabit per second, sorry, for 5G advanced. But 6G is looking for up to 1 terabit per second. That's 1,000 gigabit per second. So this is about 10 times to 100 times increase, comparing it with 5G. End-to-end latency as well. 5G was able to achieve, or is intending to achieve, because we still use 5G and we are still working on some of the enhancement in 5G to achieve this vision, 10 to 10 millisecond until 2030. Then we say, okay, we are done with 5G. We are moving to 6G proper. But I think most research now is looking towards 6G because there isn't much time. So this is about 10 times lower latency, considering the 5G networks. Reliability also, you have 10 times more reliable systems for 6G compared to 5G. You have 10 to 100 times more devices to get connected, device density, as well as energy efficiency. Although 6G is consuming a lot of energy, but the research and the work before rollout, that is why sustainability is part of the core design. So as you design system that will have high bit rate, low latency, massive connectivity, you also look at the energy consumption and how you can be able to have energy efficient system. So still, energy efficiency, we anticipate that 6G is going to be much better or more energy efficient compared to 5G. Spectral efficiency, we have seen it's about 10 times as well. So there is a lot of what differentiates the two is the basic automation in 5G, but for 6G, you're going to have completely cloud AI native kind of networks. So 5G is, the trait of 5G is transmission centric, but 6G is transmission and computing centric. So there's going to be completely change in the system, just like we did from 4G to 5G. Completely new radio changes almost everything. So 6G is also bringing this. So 6G not only for higher performance, but also for sustainability, intelligence, and inclusivity with the ubiquitous connectivity. So let's look at how mobile devices evolve through time. And while we get to 6G, what we are going to, or what we expect from 6G and beyond, or 2030 and beyond. Today, we are interacting with our systems, machines, our mobile phones. We touch, we give instruction, we text, we write. But 2020, 5G give us that kind of sensing that system can just sense some of the parameters and do some little bit traditional automation and analysis for you, but probably in some cases you have to extract the data and make sense of it and things like that. But with beyond 2030, there will be more of machine-to-machine communication than human-to-machine communication. So that means more massive machine-to-machine type of communication than you have in 5G. And then there will be computing power, because those processing and making sense of data will require a lot of resources to, like energy resources to be able to process the information. So next, we are currently in 2D era, 2D communication era, where we have audiovisual digital communication. But beyond 2030, it's going to be 3D, augmented communication, where digital experience are getting more immersive. That is why 6G have immersive communication. Beyond EMBB, we have immersive communication, where data-hungry applications like XR require much more bitrate and shorter latency, or very hyper-reliably low latency compared to 5G or ultra-reliable latency. So it will be seamless. That is the expectation or the vision. And then beyond 2030 would be more enhancement, introducing new capabilities. There could be more sensory communication. The ISAC will come in, integrated sensing and communication, where you have multisensory extension that will increase. And then you have the sense of touch, taste, and smell. Using, maybe there is this holographic communication that is still building up. We still couldn't actually achieve that, maybe due to the latency of the 5G and the bitrate. That application cannot be achieved. But when 6G is rolled out, we are going to have much more. There will be increase in data traffic in exabyte per month. You can see as you move towards 2030, you have more of this. Okay, so exabyte per month will reach up to 500 exabyte per month. Changing user behavior, the way we interact with the system will also change, where those machines that we are connecting to, giving them instructions, not needing to touch them, but just giving them information to process for us and do everything and give us the feedback, that require a lot of energy consumption. That's why I'm bringing this. So this is where the energy consumption will come from. Massive connectivity, high frequency, change in the communication pattern, then the AI and cloud native. That's device-to-device communication. Not human to device anymore. It will be less and less, but machines will communicate with each other more, which means the machines need energy to do that processing, to do that transmission, so you have increase in power consumption. So we need to know, where is that energy coming from, the source of energy, and whether it affects the environment that will lead to more greenhouse gas emission or not. So 6G energy performance, we'll look at energy efficiency. Although we have seen that there will be more energy consumption, more carbon emission, but we are also looking at how we can make the system energy efficient. This is an important area for 6G, both on the network and the user equipment side. Features like ultra-low power AI, dynamic sleep and wake capabilities could help, and energy efficiency mitigation or energy consumption mitigation. Device end features like wake-up signals and dynamic bandwidth adaptation are essential to extend battery life. So nowadays, signaling in communication, usually whether you're making call or you're not, as you move along the cells, your phone is always radiating energy. So your battery is being depleted, even if you don't make calls. So because that there is no the system that is going to check whether you need to use that energy or you don't need to use that energy. Okay, so in the future, that signaling and wake-up signals will be used to know whether you're making call or you're not making call, or when the use of energy is unnecessary to just shut the system to sleep. better energy efficiency component, and smarter energy consumption via AI controls. So using AI for telecommunication that we were talking about. So you have maybe algorithms that could be able to optimize energy use in devices and in the core network and the RANs. So energy consumption in 5G from 2021 to 2024 indicated that there is more energy consumed around radio access network RAN than the core network. But these are all aspects of a system, in mobile wireless system, that consume more energy. But it's just showing you which part, which element of the network consume more power than the other. So from this side, we can see that radio access network consume more power than all other components. So out of that energy consumption, you look at the base station and the backhaul plus core control systems. This consumes more energy. So the total power consumption is the baseband unit power consumption, the radio resource or radio unit consumption, and then power amplifiers and the overhead, like cooling the base stations and the powering the systems themselves. So you expect also to see more of power consumption considering the base station area coverage in 6G compared to 5G. But in terms of energy per bit consumption, 6G consumption is lower. Why this is? Because on the side, on A is energy consumed per base station. So it means that you have more base stations in 6G than base stations in 5G, which is going to contribute to more power consumption. But you transmit more bits using this than in 5G. So in terms of coverage with the network, you consume more power with more cells, more base stations. But in terms of energy per bit, 6G is going to be more efficient. Area scaling, areas that you can cover based on the power usage. You can see, yes, in terms of area, you have higher consumption for 6G. But in terms of throughput scaling, you have less, you have more energy efficient system in 6G. Okay. Again, looking at the coverage area, look at the, is it blue? This blue is 4G. It means it can cover more, like 2 times area that 5G can cover, or more than 2 times. But the dot one is the 6G at greater than 24 gigahertz. You can see it covers less area, maybe even you need to multiply by 2 or 3 cells for you to cover the same area that 5G covers. And then we know that the energy consumption per area is the total energy consumed that we have over the unit area, the area that we intend to cover. So,
okay, sorry, Prof. I can see that you have a lot of slides, and we are running out of time.
Okay.
So can you maybe quickly run up, like in 5 minutes?
Okay. All right.
But I'm really enjoying it, but we don't have much
time. Let's move to maybe because this all equation. So you have a background now that there will be a lot of energy consumption due to the high frequencies, more connectivity, user density areas to cover. So that is where the energy consumption comes from. So let's move to strategy of minimizing this. We expect to design system that saves energy. We use the switch off on unnecessary hardware sites, radio access technology, and then we reduce the number of antenna elements. Though we need MIMOs, but there is a design for reconfigurable intelligent surfaces that can reconfigure themselves, that they direct the beam to the required site. Sustainability is a core design requirement, as I mentioned. Security, ubiquity. So let me move to the metrics for carbon neutrality also, but no time to discuss this. So, but we are going to use also renewable energy systems in mitigating this. for especially some systems, base stations, and in space, like for the non-terrestrial systems. And then we're going to use some parameters to measure the renewable energy utilization rate, renewable energy carbon offset factor, to see whether we achieve some reduction in greenhouse gas emission. Okay. We look at also carbon neutral, the emission summary. If you look at the table here, around 2017, there is more carbon emission, greenhouse gas emission. But as we move to 2021, it keeps reducing. But around 2022, we have return that maybe 5G and then 6G. So we expect to see this increasing if action is not taken when 6G is rolled out. And then we have electricity consumption with about 26, so which we know telecommunication networks will be using electricity to power cells, base stations, radio equipment, and user devices. So definitely there will be more connectivity in the future when we move towards 6G, and then the ITU projected significant rise in global mobile traffic, as I showed that above, that there will be increase. Then energy consumption, global energy consumption will lead to global energy consumption, will lead to increase in carbon emission from RANs, core networks, data centers, user equipment will all contribute to more carbon energy consumption. Net zero commitments are driving sustainable network design. So let me, but there is an agreement targets 50% carbon emission reduction by 2030. And then net zero by 2050. I hope we can achieve this when 6G is roll out. So there are some technologies, key enabling technologies that 6G is going to be using, where the role of industrial electronics will come in. Role of smart energy systems will also play a part. So we know that we need data to be able to get the to have an accountability for carbon emission. And then let me move because you have time. So roles of industrial electronics and smart energy system. To achieve this, we need to deploy renewable energy systems, smart grids, intelligent systems, AI-driven techniques within the base stations, radio access networks, core networks, and then the user devices for energy, reduce energy emission. We can use technologies like energy harvesting and zero energy commission, where you can harness energy from either electromagnetic waves or the thermal energy, and then convert it to electric to power the system, and then also from solar radiation. Effective RAN architecture, where we have open RAN, cloud RAN, and also the fog RAN as well. Reconfigurable intelligent surfaces that direct the antenna beam to space peak location, reconfigurable holographic surfaces as well, and then renewable energy sources deployment in most of these stations. Efficient energy storage and cooling, cell-free, cell sleep, and energy saving modes. So these are some of the technologies that can be enabled. Okay.
Thank you so much, Prof.
All right. So,
I guess you have a lot. Maybe you just share the slides. We have the slides, and maybe we have you another time, so that we'll.
Okay, let me just take down to the last slide. So thank you very much, Amina, for inviting me. I think we have not started early. We spent some time trying to solve the technical
issues. That wasn't. No, it's okay. You prepared so much for the presentation, so we really learned a lot. So thank you very much. Really appreciate. So we'll be taking the questions and answers. So you have any question, please, you can indicate by raising up your hand and you unmute. And then in case you can't speak at the place you are, you can drop the question at the chat box, then we can read it out. Thank you so much.
Okay, so can I stop sharing?
I think I will put first. Yes, you can stop sharing. I think I have a question. All this you are talking about, you didn't, there's one thing you didn't factor out, the cost. The cost on the consumers. I didn't see anything about cost. We Nigerians, we are more concerned on the cost.
Yes. Okay. So cost of what? Because is it cost of connectivity, cost of energy?
Cost of data to we the
Mhm.
consumers. So is there any, is the cost going to increase now that everybody is going to be on using, maybe we have a smart houses, our mobile phones are connected, smart TVs and the rest. So is the cost of data going to increase for the end users when the 6G comes?
Really, that that is not a concern, because as technology evolve, usually we have reduction in cost. So we have a reduction in cost of data, even reduction in the cost of devices. So as we connect, this enhancement are not going to increase the cost of that connectivity, because you have more competition. When you integrate, now maybe some areas, if you don't have terrestrial networks, you are out of coverage. There is nothing you can do, whether it's expensive or you're going to pay much or less, you're not going to get connectivity. But as the system integrates with the computators coming into the market, like satellite industry, having interoperability with terrestrial networks, then the cost will reduce because there is more competition. So I don't think cost is going to increase in terms of data cost or equipment cost. It will reduce even. I hope that answers briefly your question, Dr. Amina.
Okay, thank you very much for that. So we have few people raising up their hands. Hadiza, please, can you unmute and ask your question?
Good afternoon, and thank you for this insightful session. My question is towards the practical side of the communication between remote infrastructures. If you have solar mini grid.
Hello,
I
Hadiza,
can't
we
hear
can't
you.
hear you clearly.
I said my question is toward practical side of communication between remote infrastructures. For example, if you have two solar mini grids in two different villages, how do they actually exchange data, and what hardware will be involved? Thank you.
All right. Can I go ahead and answer this, or I should allow Dr. Amina to answer?
No, you can go ahead, sir, Prof.
Okay. So, these are, you see, there is the solar mini grids are, I think, part of the system. So some of them, it depends on the data you're trying to exchange. Is it data that you want exchange in real time, or it is a data that is on demand? So in real time, yes. So in real time, there is this system called Smart Grid Communications, where they have data captured from renewable energy sites to be transferred without even using you can use satellite, one, if they are in remote locations. You can use satellite link, because probably now we have low Earth orbiting satellite by Elon Musk satellite, Starlink satellite. So they are fast. They can do the real-time application of most of this mini grids in remote rural areas. So what will help us is whether at this point in time, maybe we have to use satellite terminals on those sites. We separate ourselves from the terrestrial networks. But in the future, what do? You don't even need the satellite terminals separately to be able to transmit data from those remote locations. And that is the ubiquity that 6G is coming with, that everywhere you have connectivity everywhere, and depending on the application, you choose the network of the best network to use. So even today, we may be having a hybrid of different networks, but depending on the application. If you're watching football match, it's not maybe terrestrial system, it's satellite system that still looks seamless in real time. And then if you're navigating probably GPS data and stuff like that, you may be able to link between the terrestrial and the non-terrestrial systems. So transmission limitation is going to be like the transfer rate is going to solve that. You will not have problem in terms of bit rate. You don't have problem in terms of connectivity because 6G is addressing that. And then probably the storage, because there is a lot of work on data centers where you have huge storage that you don't need to bother yourself. So this will only contribute to energy consumption, but they are trying to also solve a lot of problems. Okay. I hope this answers the question.
Yes, thank you very much, Prof. So we could, the next person is Jude. I can't see that. Jude Ofo. Please, you can unmute. Hello, Mr. Jude.
That is Engineer Jude Ofogu.
Okay, sorry.
Okay, so sorry, I'm Dr. Amina. I know there are a lot of questions and there are a lot of answers required from Prof. A lot of queries. In fact, I'm enjoying the presentation from the start up till now. So I just told them, Dr. Amina, to also relate to Prof that we're also scheduling him our IAS workshop coming up during NigerCon at Lagos. So, Prof, please kindly oblige to be in Lagos for our workshop.
When is that going to be, Engineer?
Sometime in November.
November, okay.
Yes, we need
hopefully
to.
I will be around then. Inshallah, I will.
You have. So, Dr. Amina, please, it's not as if I'm cutting you short. Let's hear from our second presenter. He has something in education that will benefit university lecturers and so on and so forth. Let's hear from him, then we can add up all questions together and answer. Yeah, thank you.
Okay, sir. So let's invite the second presenter from EU Educate, presentation by Bharat Sunaram and team. So you're welcome. Please, you can introduce.
Yep.
yourself.
Good evening, everyone, and thanks for the opportunity to present U-Educate in front of the scholars and academicians. And my name is Bharat Sundaram. I am coming from India. I represent a company called U-Educate, which is an educational technology company which provides end-to-end educational solutions to the institutions. Starting, we cater to K-12, engineering, higher education, polytechnic, diploma, TVETA, as well as for the medical institutions. So we provide 3 products, which is all integrated, like ERP, then communication technology, and we provide the content management. In our ERP, we provide all the enterprise resource planning, which is required for the educational institutions to run smoothly. The main unique of our ERP is like we have a integrated online video classes, which has been much powerful than Zoom or Google Meet. And all the data will be stored within the server of the institution only, and there is no need. All the data will be secured, and there is no need to fear about the privacy and the piracy of the content. And in our timetable management, what we have done is like a task which can be happening for 10 days can be customized in couple of hours, so that the entire institution timetable management is automated. That way we have done. And from the timetable management, a teacher or a student can join or initiate the online video classes. That way we have developed our product. And in our communication technology, what we have done is like we are ensuring a educational institution that there is no need to depend upon WhatsApp or Telegram or for emailing like Google Mail or Yahoo Mail or Hotmail, and for any video classes like Zoom meeting or Google Meet or Windows Team. We have integrated everything within our communication technology. So on click of anything, if I want to send an email, click on the email, I can initiate an email. On click of connecting with the students through online, I can do that one. And on click of sending a messages, it can be done. So that way we have integrated. And the content management, we have an extensive research which has been done in that, which is more powerful than the PDF, which has been approved by the educational apex body of India, in which what we have done is like we are providing a offline version of the entire book, which has been integrated with all the essential requirements for the educational institutions, like keywords, 2D animation, 3D animation, lesson plan, videos, everything is being integrated. There is no need for your students to look out for online. Everything is going to be available to the students through offline. So with this, I just make a pause and I'll just show you a demonstration about my product so that you will have a full idea about that one. Just a minute. So this is the dashboard of the screen where the entire 30 ERP modules has been integrated, starting from the admission till the exit of the student, whereby the fee management, transport management, everything is been handled, the diary, the attendance, everything is been handled through this ERP. The specialty of this is the timetable management, where I click on this view mode. You will have the entire session of the particular day is being shown here. And from here, like I will be able to move on to the online classes. So the specialty of my ERP is like wherever you see this blue color icon, video icon, through this video icon, you will be able to connect to the students without having Zoom or Google Meet or Microsoft Teams. You can directly connect and teacher can initiate and students can join the meeting. So that way we have given it. So no need of dependent of any third-party video class sessions. And the advantage of our timetable is like from the timetable itself, I will be able to jump on to the particular lesson, particular topic directly. Click on that session 13. So the particular topic is being integrated. Now, this is my CAT book. Wherever you see the left-hand side, this is all the learning curve of each and every student. How much the student has covered on the particular unit. Here we are giving a split up of lesson wise also. So click on this one. You will be able to see on the lesson wise, the entire unit wise. Now, if you click on that percentage, you will be seeing the additional features of what has been covered by the student on 2D animation, what he has gone through, how many topics, how many lessons he has gone through, you will have it. And the major advantage of this is like on the fly, you can convert the entire book into your own language. Say, as a student of Arabic, if I want to learn the entire book in Arabic, the book will be converted into Arabic. So that facility is available. Now, there will be some students who will be interested to learn through audiobook. So we have given, I'm just coming back to English. We have given the audiobook attached to that.
5.7 Translation. Translation refers to the process of polymerization of amino acids to form a polypeptide.
The entire book is available to the students through a audiobook. So that facility is available. Along with that, you click on the particular lesson, scroll down is available, and wherever you notice a blue color word, this shows that this word has lot of key additional information available. So as a teacher, when I am teaching, I will be teaching about the word called androecium. So when I'm speaking about androecium, then I will be opening a new window to give meaning regarding this androecium. Now what we have done is like click on androecium. The details of androecium is available on the left hand side. No need for me to open a new window to learn anything. Likewise, while seeing the videos, the video will be available within the book.
For personal makeup.
So as a teacher,
a fascinating organ of angiosperms.
I can show that video in the left hand side and I can show the book on the right hand side so that they can understand about the learning through video as well as through the book. So that way it is being integrated. And
flowers have served as an excellent offering to God.
While I go through the video, if I am not able to understand the pronunciation, I am giving all the
flower
related to that one. The entire video is being transcribed for the benefit of the students. So the students can go through the video and they can understand the transcript of the video within the bottom of that one. Now, if I have some clarification to ask a teacher, say like, what is the meaning of reproductive? So I double click on that. I can click on clarification. So my ask a doubt window is being opening to the students. Now what we have done in the speciality of this is like whenever a student is asking a clarification, all the other 39 students or 25 students of the particular class will get a notification. So there is no need for a teacher or a faculty to give multiple replies to the same clarification. So a teacher can give a reply to the one particular question and all the other students will get notification about the answers. So that way we have made our clarification of a community chat. That way all the students will get benefit from one student inquiry. So that way we have made it off. Likewise, you select it. We have integrated annotations like notes, highlight, hyperlink, and we have integrated AI search, chat GPT, all the things like you can create a. So we have integrated all the elements which is required for the learning for the student is being integrated. There is no need for you to subscribe for anything additional. It's all been integrated, subscribed, and it is available to the student through offline methodology. But whenever the student wants to ask a clarification through ChatGPT, then you have to be online. Otherwise, seeing the content, seeing the video, seeing the simulations, everything is going to be available to the students through offline. So I have multiple search, I have dictionary translation, encyclopedia search available. So likewise, we have integrated all the requirements for the students. Along with that, like we are providing study material with the question and answers, and along with that, we have assessments.
Okay, so thank you very
Just a
much,
minute, just
bro.
a minute. I'm just completing it. Okay.
Okay.
Everything is provided, and we are customizing this as per the syllabus of the particular institution, and we provide. So we have content readily available for K-12, engineering, diploma, TVET, and then for medicine and for higher education. With this, I'm just pausing. Any clarification, you can ask me now.
Okay, thank you very much, Prof. Before I hand over to Dr. Amina, considering what we just heard about migrating from 5G to 6G 2030, my question or my query is regarding what you've presented and you said will go offline. It is only when we want to get clarification from ChatGPT or what other platforms, that's when we'll come online. So I'm talking about data consumption. When we improve, like when we migrate to 6G, will the data consumption on this model of yours be greater or it will be lesser? Or currently, the 5G we are using, considering data consumption, will it be less? Is it lesser using your platform or it's higher? That's my question.
It's going to be lesser because the normally what happens is like if you use 2G, 3G or 4G or 5G and currently now the 6G, the data consumed in 6G and 5G will have a variation because based upon the speed of the internet provider, you will have more information which will be shared to you within a short span of time. So the data consuming will be lesser than each and every the 6G, 5G, 4G like that.
Okay, thank you, Dr. Amina. I hand over to you. You have the floor. Thank you.
So thank you very much, sir, for the nice presentation. This is a nice application. Thank you. So I think we can go back to our question and answers. Engineer Jude to ask his question. This is our prof still around? Prof, are you still here?
Yes, Dr. Amina, I'm here.
Okay, thank you very much.
Is it about our presentation? There will be questions about my presentation.
Yes, so
Okay.
I think some people's hand were up, so we would like to invite Engineer Jude to ask his question.
Yeah, anybody that has queries should ask to any of the presenters. Yeah, thank you.
I was locked out of this device. There was a question on the chat box. Please, can somebody read out the question about, I think, a project topic? Please, I was locked out, so I don't have the chat. So there's a question on the
so let me read
chat box. Somebody was asking.
Okay, so from Shanef or Sharif, he said, if AI assistant begins collaborating directly between, okay, let me start from Ademola. Ademola said, no doubt about the positive impact of 6G, especially in increase in compute, higher data rates. So his question is, how does 6G help inclusion of locals, especially in areas affordability of compatibility and end users device?
This question is for me, Ko?
Yes, for you. Then he has another one.
All right.
If you can answer the both of them together.
Okay.
So
yeah, you can. The first one is asking about. Can you just?
How does 6G help inclusion of locals, especially
Okay.
in areas of affordability of
Yes.
compatible end user
Okay.
device.
Inclusion. All right. Okay. Inclusion and interoperability question. Okay. Next. Oh, should I answer this?
Yes, you can go ahead.
Okay. So I think 6G come up with this use cases and capabilities to, there is this issue of connecting the unconnected. So remote rural villages, unreachable areas where the terrain is difficult to reach by terrestrial networks will be covered by satellite systems. Also, there is also some proposal for drones technology, like drone technology that can carry internet to that to remote rural areas. And then there are a lot of projects on regarding the affordability. If the villages cannot afford it, I think there is a concept that some people can pay for others, just like the way we have the television reception. Most African countries cannot afford to pay for the satellites that are launched for television transmission. But European countries and United States, a lot of people can pay. So, and you have same footprint because it's a broadcast kind of signal. So you're utilizing the same resources with others that can pay more than you. So it will become cheaper as well. It's not going to be more costly because another cost effectiveness that can be removed is through interoperability of the devices. If I don't have to buy Elon Musk's CP equipment to install in my house, that reduces the cost. I can buy just a mobile device, which I think there is a proposal also called Integrated User Equipment, IEU, for 6G networks. That device can access satellite network and can access also terrestrial networks. So you're using seamlessly same device that could also be cheaper because these are visions. 6G is not yet rolled out, but the work is ongoing to make it interoperable and to make it inclusive. So, and inclusivity is one aspect that 6G is bringing that 5G doesn't have. That is true ubiquitous connectivity. I hope this answers the question.
So thank you. We're targeting 4:30 to round up this section. So there's some concern about the effect of frequency intensive now energy intensive technologies such as 5G, 6G on human body or tissues. Tissue. How is the industry ensuring that manufacturers implement and educate end users about specific absorption rate of devices?
Okay, great. That is a very good question. And it's something that I have been wanting to do regarding this. Maybe a public lecture can be done on this. You see, the effect of RF or radio frequencies, the way people look at it, it's not the way it's being sold to people that this is going to cause harm. This RF frequencies up to terahertz frequencies that we are using for communication are called non-ionizing radiation. The spectrum has two aspects, ionizing and non-ionizing radiation. So ionizing radiations are the one that can maybe have a kind of tendency of mutation of genes or that can cause cancerous, like X-ray or gamma ray, you know, when you go beyond that of communication frequencies. But the only effects health-wise is the exposure, in most cases in the form of heat. So the antennas, the base station antennas and your mobile phones have a particular standard of power radiation per meter square, per unit area. So when it exceeds that, then we can talk about the heating effects of the system. So that heating effect cannot cause cancer, cannot mutate your genes, but it can, let's say it's a heat. So it's like you're cooking something. So it may aid the, you know, what can I say? Maybe it may aid the process, but it is not going to cause it. Remember the debate on 5G, when 5G was rolled out, a lot of people were like skeptical on it. Like if you have 5G antennas, you are exposed to this frequency, and it causes, some people even say it causes COVID, if you remember. But that is not the case. I work on 5G frequencies during my PhD before the rollout, and I'm still healthy. So the heating effect, as when you are making call, the phone is on your, let's say, on your cheek, you can feel the heat as you're using the phone. So that heating effect, it can cause maybe damage to your skin or something, but not causing cancerous or causing cancer or causing another disease just by it, just like the way X-rays or gamma rays or nuclear radiations can cause problems for your body. So we need to understand that communication frequency are not within the ionizing radiation. Okay, so the effect is on heating effect. This is my my opinion on that. But still, if you can measure with some radiometers that you can test the RF radiation value, I think check the standard from ITU. And if you're far away from that tower station, from that towers, I don't think you can have that heating effect in your body or in your system. So there is radiation, but radiation in a different form. It doesn't have that energy to be able to destroy cells or to do something harmful.
Okay, so one last question, Prof. If you were supervising undergraduate engineering students today, what practical projects would you recommend that could contribute to sustainable 6G technologies within the next 3 to 5 years?
Yes. So there is a lot of work. I will suggest one thing: incorporating AI for optimization, monitoring, and management of power systems within the base stations, and then maybe incorporating some algorithms for the user device to be able to adjust the energy use, like the sleep mode. There is on-off kind of proposal for devices, like if you're not using them, they should go to sleep. When you're using them, they should come up. So AI can help to enable such systems. So that is one. Second thing is, I will still use the integration of terrestrial and non-terrestrial systems, because already we have satellite in space. We are using solar energy, and they are not going to produce, we are not going to use fossil fuels to power them. So we already have a kind of, reduce in the energy consumption on the terrestrial systems, and that could reduce the carbon emission. Okay, so that is more of green communication area. So this is that.
Oh, Prof.
Okay, thank you.
So much to learn. That's why I've learned for the workshop. So that being said, the reason for Rama's presentation is to also reach out to those of us in the academia to also see whatever application is which he has built, and to also see how we could implement it in the universities or home made studies and so on and so forth. So please, he has shared his contact on the WhatsApp platform, sorry, on the chat box. Please do well to see how you could also reach out to him to patronize whatever thing he has in stock. So thank you, and thank you so much. Tamina, yeah, you have the floor. Thank you. Yes, before we go into group photo, I want to say special appreciation to our speakers. It was quite an enlightening section. I want to also thank everyone who stayed from 3 p.m. when we started up till now. It's not easy, devoting your time, money, data, expenses, to be here. Thanks also, Prof, for finding time to be with us. The knowledge sharing, putting this work together, it's not easy. In fact, that's what most of us are looking for. I know if it's a paid event, I know how much we pay for these kind of presentations. So, like I mentioned, we look forward to collaborating with you and to also see that we have a student branch chapter for IES at Bayero University. I'm anxiously waiting and looking towards that.
Thank you.
Thank you all for joining, and we
Right.
go to the photo section. Yeah, thank you. Put on your camera.
Okay, thank you very much. So I have dropped the link to Prof's page on LinkedIn in case anybody wants to reach out and you have any question for the students that needs mentors, you can reach out for Prof. I am sure he's open for mentorship as well. So thank you very much. So we can put on the camera.
Dr. Amina, please, can you take the photo from your end?
Okay, no problem.
Okay.
So at the count of, are you ready? At the count of one.
No, I think he needs to stop sharing the screen so that the photos. So please kindly stop sharing. Okay, thank you. So
Awesome. I can see Vincent Olema joining us from, I don't know if it's US or Uganda. So where are you joining us from?
I'm from Kampala. Yeah.
Kampala.
I'm from Kampala. Next year, you guys will come and join me here. Come and see my beautiful country.
I'll come there soon. Thank you so much.
I know this year engineer we're going to meet in Nairobi finally.
Yeah, we'll be there. Thank you.
I'll say
So,
engineer who?
Koto, can I take now?
Yes. Please go ahead. Unfortunately, I'm in an area where I can't turn on my camera.
Okay, so I have taken.
Okay, how many? Take more, as much as you can. I can also see, Taiwo on the call. A lot of people are Demola, Chinemerim. Thank you all for joining. I can see Sheriff Sylvester. Yeah, I can also see Yakubu. Sorry if I've not mentioned.